A0 माइनस है वो बोल रहे हो आप?
हाँ यार, इन दैट इज नो is A naught minus A is equal to
KT.
KT.
KT. Very good. Is equal to KT. Okay. Now, write the topic graphs. First, we are going to look at the rate versus concentration of reactant. First graph is rate versus concentration of reactant. Now, for rate is equal to rate versus concentration of reactant, we have only one particular equation, and that equation is R is equal to the rate constant K. For a reaction, A is going to give me product. For this reaction, K into A to the power how much? Tell me. If it is a zero order reaction, A to the power? A to the power what? Tell me, guys. For zero order reaction, what will be the, yeah, very good. 0. That means we can say that R is equal to K. What kind of graph will be here? If I plot between the concentration of A and the rate, so as you can see, rate does not depend on the concentration of A. So no matter what the concentration of A is, rate will be constant. Okay, rate will be constant. That means even if you have very high concentration or you have very low concentration, the rate of reaction is not going to change. The rate of reaction is not going to change because it is not dependent on the concentration of the reactant. Please make this graph. Let me know when you're done. Done, guys? Yes or no? Please tell me.
Yes, done.
Write the next graph. Concentration of reactant versus time. So in this case, my y-axis is time, and my x-axis is time, and my y-axis is concentration of the reactant. Okay, concentration of the reactant. Now, if you look at the equation in which we have the concentration of reactant as well as the time, it is the integrated rate law equation, that is A naught minus A is equal to KT. Now, in this case, you can see this plot as, also write this as y is equal to mx plus c. What is your y? Y is the concentration of A, so that will be concentration of A. It is equal to mx. Mx will be what? What is x? T, and whatever term is corresponding to T, that is your m. So if I bring this here, so it will be what? Minus KT plus A naught. So this is my y. This is my, this whole minus k is my m. This is my x, and this is my c. Okay. Now, when the time is equal to 0, when the reaction has not started, we will have all the reactant, and it is going to start like this. There is too much of reactant initially, and slowly it is going to decrease. Okay, so this is the slope, and this is the intercept. So this is A naught, the concentration of A at time 0. This is slope, that is equal to minus k. तो दोनों ही चीजें बहुत ज्यादा इंपॉर्टेंट है. You will get direct questions which will ask you which will say that this is the slope and this is the what. No, they will just give you the graph and they will ask you what is the order of reaction, what is its slope. So please write this down. Done everyone? Yes or no? Please tell me.
Yes.
Right, next. First order reaction. We are going to look at the integrated rate law equation of first order reaction. Okay. Now for first order reaction, we have A giving me some product P. The rate of reaction will be equal to rate constant K into A to the power. How much? Please tell me, guys. A to the power?
1.
A to the power 1. Very good. I can also write R is equal to minus dA upon dt, minus dA upon dt. Now what I'm going to do, I'm going to equate both of these things. So I will get minus dA upon dt should be equal to K into concentration of A. Now I will do variable separation. I will get minus dA. I will put the A terms in one place and I will put the T terms in one place, K dt. And then I'm going to integrate on both sides. So I will get integration of 1 upon A dA is equal to K into integration of dt. Okay, so I'm going to get here integration of 1 upon A, it is equal to ln A. Okay, integration of 1 upon A, it is equal to ln A. Oh, sorry, I will have the minus sign here. So this minus sign will also be here. Okay, I forgot this minus sign. This will be equal to KT and there will be a integration constant C. Now, in order to calculate C, if you remember from the zero order reaction, in order to calculate C, we do at time is equal to 0. Concentration of A is equal to A naught. Concentration of A, it is equal to what? A naught. So I will write minus ln A naught is equal to K into 0 plus C. So I can write the C is nothing but it is minus ln A naught. Now I will plug in this value, substitute value of C in equation 1. Which is my equation 1? This is my equation 1. Now when I'm going to substitute this value, I am going to get, what will I get here? I will get here minus ln A is equal to KT minus ln A naught. Minus ln A naught will go there. You will get ln A naught minus ln A is equal to KT is equal to KT. Now we know that ln A minus ln B is equal to ln A upon B, right? Ln is nothing but log. Okay, ln is equal to log with the base of E. Ln is equal to log with the base of E. So I will get here ln A naught upon A is equal to KT. Okay. Now we don't do any calculation with the natural log ln. We do it with log. So in order to convert it, I will write 2.303 log of A naught upon A is equal to KT. It is equal to what? It is equal to KT. You can also write this as log of A naught minus log of A is equal to KT upon 2.303. Okay, so this is the equation. Please write this down. Let me know if you have any doubt. After this, we will look at the graphs, okay? Is there anyone who is still writing? All of you are done? सबने लिख लिया? अब्दुल फहद, समायरा?
1 मिनट सर, 1 मिनट, लास्ट।
अच्छा अच्छा, जी जी जी, नहीं नहीं तो बोलिए ना आप, बोलिए, हम रुक जाएंगे, कोई दिक्कत नहीं है। ओके एड्रियन। हो गया? एड्रियल एंड ज़ैड डन? यस, जैन डन?
हाँ सर, हो गया।
ओके, चलिए ठीक। Now write graphs. Please write number 1. Rate versus concentration of reactant. देखिए, rate versus concentration of reactant में always we are going to use which equation? The rate law expression. Okay, what is the rate law expression? Rate law expression says that for first order reaction, R will be equal to the rate constant K into the concentration of A to the power 1. Now, this is a equation which is very similar to y is equal to mx. Now, in y is equal to mx, what is my y? My y is rate. And what is my x? X is my the concentration of A. As we are going to increase the concentration of A, the rate is also going to increase. That means it is going to pass through the origin. It's going to pass through the origin like this. Okay. And what is going to be the slope? Slope will be equal to the rate constant K. Is anyone speaking? I can't hear anything. कोई कुछ पूछ रहा है क्या? No? Okay. Copy this down. लिख लिया आप लोगों ने? Please tell me. Done, guys?
Yes, sir.
Right, next. Concentration of reactant. Versus time. Now for this, we are going to use the integrated rate law equation. Now we have two, and we are going to look at both of them. We have one which is log. We have one which is log of A naught minus log A, that is equal to KT upon 2.303. Okay. Now I will write it like this. K upon 2.303 into T. I have to write this in the form of y. देखिए आपको दो इक्वेशन हमेशा याद रखना. Okay, always two equation. Y is equal to mx. इसका ग्राफ कैसे होता है? Passing through the origin like this. Okay. If this m is positive, if this m is negative, then negative आपके केस में होगा नहीं. ठीक है. Physical sciences में you will not have m negative when you are having y is equal to mx. Another graph is y is equal to mx plus c. अब इसी में ही आप एक कांस्टेंट c को ये कर दीजिएगा. Okay, so you have the same slope. Let us suppose this m is same, this x is same, this y is same. You have just added a constant c. That means it will be like this when the m is positive. But for this case, if m is negative, then the plot will be something like this. ठीक है, इस तरह से plot रहेगा. You have a c constant here, and the slope is decreasing. And the slope is decreasing. That's the only two things that you have to remember: the slope and the constant. Constant will be always positive in chemistry. The constant will be on the positive y-axis. And m, that is the slope, it can be positive and negative. Positive slope, that means if the x is increasing, y is also increasing. So like this. Negative slope means if when x is increasing, y is going to decrease. So x increases like this, y is going to decrease like this. So it is going to be like this. This is my negative slope. M is equal to negative. Okay. So have a like rough idea about these graphs, so that you know what is slope and what is intercept. At least these things. Okay. Now I will write this in terms of what y is equal to mx. Now what is my y? The concentration of reactant. What is the concentration of reactant? Log A. So I will keep the log A positive sign. So it will be log A is equal to. Now when I have added positive sign, that means I have multiplied negative to all of these things. And I have also put minus log A naught that side. So I will get KT. Others I will get minus K upon 2.303 into T. And what I am going to get? Minus log A naught, it will go there, that will become plus log A naught. Okay, just make sure that you understand this question. Please don't copy if you don't understand this equation. Okay, how did we get this equation? Very simple maths. थोड़ा सा दिमाग लगाइए, please skip मत कीजिएगा. Okay, थोड़ा सा दिमाग लगा के समझ ही लीजिए. Now what is my y? Log A. And what is my x-axis? My x-axis is T. Now, first of all, look at C. Do we have C? Yeah, we have C. Is C positive? Yes, C is positive. So C will be here somewhere. And then what do we have? We have negative M or positive M. We have negative M. That means the slope is what? Slope is negative. So when slope is negative, it is going to be like this. Okay. Slope is negative, it is going to be like this. Got it, guys? Yes or no? Please tell me. अब यहाँ पे देखिए आप लोग, slope is equal to minus of k upon 2.303. Okay, and this is what? Log of a naught. Got it? अरे आया कि नहीं आया समझ में? हाँ गाइस, एड्रियल अब्दुल
Yes,
रहमान
sir.
आया ना? हाँ तो कुछ तो बोलिए, ठीक है? So see, you will also get very similar graph. I have also one more version of this. Na? It is what? ln a naught minus ln a is equal to kt. Okay. Now in this case, what I will write, y is equal to mx plus c. How it will look like? It will look like this. ln a is equal to ln अभी नहीं लिखते हैं. First of all, let us write kt. Rather, it will be minus kt plus ln a naught. The plot is going to look something like this. Very similar plot. Nothing is changing here. What is changing here? Two things are changing. This is my time and this is ln of a. This point here, this is ln of a naught, and this slope here is equal to minus k. Okay, here it was minus k upon 2.303. Here it is minus k. So remember these points. So very similar graph. Please let me know when you are done. Now, right next. Half-life period. Half-life period, it is also known as T half or T 50%. Okay, it is also known as T half or T 50%. Now please write the time required for what is half-life. Half-life is very simple. Okay, half-life is very simple. If you start with 100 moles of reactant, what time will it take to get to 50%? What time will it take to get to 50%? That means 50 moles. If you start with 2 moles, what time it is going to take to convert the reactant or to reduce the reactant to 1 mole? Okay, if you have, let's say 4, then half-life will be the time taken to reduce the reactant to what moles? Tell me, guys. If you have 4, I will reduce it to 2. Okay, if I have, let us suppose A moles, then I will reduce it to how much?
A by 2.
Very good. A by 2. Okay. Yeah. Anything, whatever you are having, that is divided by 2. So please write here the time required for %50 completion of the reaction is called half-life period, or the time during which the time during which initial concentration of reactant is reduced to half is called half-life period. I hope all of you have written. Now write the topic. Now we'll look at the half-life period of zero order reaction. Right, number 1. For zero order reaction. What is the integrated rate law equation? Integrated rate law equation क्या बताइए जरा zero order reaction के लिए? A naught
minus A is equals to DT.
minus A is equals to KT. Now, when time is equal to T half, that means we are looking at the time in which reactant molecule is half. What will be A? The final concentration of A should be A naught by 2. Right, guys? Yes or no, please tell me. Final concentration of A will be A naught by 2. Now I will write it very easily. Now T half is equal to A naught minus A naught by 2 divided by K. Correct? Now, A naught minus A naught by 2 is equal to what? The 1 minus 1 upon 2 is equal to what? Half only. So A naught minus A naught by 2 will be equal to A naught by 2 and whole divided by K. Okay. Then what we can write? A naught upon 2K. So T half will be equal to A naught divided by 2K. Also write plot for T half versus A naught. As you can see, y is equal to mx kind of graph is here. We don't have any constant that is c, right? We don't have plus c part here. So we have T half in the y-axis. We have initial concentration of A. Now it is going to increase. That means if we have more A, then it is going to take more time in order to get the half of the reaction. Okay, so it is going to increase as we are going to increase the concentration of A. Also, I can write the slope is equal to 1 upon 2K. Done, guys? Yes or no? Please tell me.
Yes, sir.
Let's write next. Now we are going to look at the first order reaction. For first order reaction, I can write T is equal to 2.303 divided by R. Sorry, divided by K, not R, log of A naught upon A. Then I can write when time is equal to T half, the concentration, final concentration of reactant A will be equal to A naught by 2. Okay, it will be equal to A naught by 2. Now I can write T half is equal to 2.303 divided by K log of A naught upon A naught by 2. Okay, now this will be equal to 2.303 divided by K log of this 2 will go above, and A naught will cancel each other out. Okay, now this complete thing 2.303 into log 2, it is equal to 0.693 divided by K. So T half is equal to 0.693 divided by K. If you look at the plot here, and if you look at this particular equation also, you can see that there is no term which is of the reactant. A naught is not present. That means the T half-life of the first order reaction is independent of A naught. Plot for T half versus A naught. This is for first order reaction. So this will be equal to what? This will be something like this. We are having T half here, and in the x-axis we are having A naught. Write a note. T half for first order reaction is independent of initial concentration. T half for okay, Fahad. Please let me know when you are done, guys. Okay. Done. Is there anyone who is still writing?
Still,
Still writing? Okay. Please write then. I hope you're writing the note part, okay? Okay, done. Please write a question. T half for first order reaction. Okay. For a first order reaction, T half was found to be is 2 minutes. Determine the time taken. Determine the time taken to reduce the concentration of reactant from 16 moles per liter to 8 moles per liter. बताइए कितना टाइम लगेगा? If I'm the T half is given as how much? देखिए 2 minutes, right? So if I'm going to do half of the 16 moles, how much time will it take? Tell me guys. कितना टाइम लगेगा? जल्दी बताइए. Yes. Huzaifa correct. Adriel correct. Zan, can you explain why you are answering that? Yes, Zan, tell me. हाँ, Zan अब सही है आपका. अच्छा, गलती हो गया था. Samaira, can you tell me why you are answering that? No. देखिए, हाफ लाइफ का मतलब क्या होता है? प्लीज टेल मी. फहद, हाफ लाइफ जल्दी बताइए. What is half life, Fahad? What is half life? अरे turn your mic on, Fahad. हाँ.
Yes, sir.
Yes, बताइए. What is half life?
The time during which initial concentration of reactant is reduced to half.
Reduced to how much? Reduced to half. What is the initial concentration?
Yes.
What is initial concentration is yes.
16.
अरे what is 16?
16.
Okay, so and we are converting it to how much? 8.
8.
So half हो रहा है ना ये? 16 to 8
Yes,
is
sir.
half,
16
right?
half.
16 to 8 is half, right? So, and how much time is it taking to half the reactant? Tell me. जो T half क्या दिया हुआ है बताइए? How much time does it take to half the reactant? Tell me. How much time to
2 minutes.
half the react? 2 minutes ना? यहाँ पे भी तो half ही कर रहे हैं, so it will take 2 minutes only. क्या दिक्कत है इसमें? All of you got this? Yes or no? Please tell me, guys.
Yes.
Okay. Now you tell me. If I am going from 8 moles per liter to 4 moles per liter, then how much time will it take? बताइए. 8 से 4. Again half है ना, तो क्या होगा? जल्दी बताइए. Once again, it is the half, right? How much time? Yes, Fahad, tell me how much time?
2 minutes.
Yes, Samaira, Abdur Rahman, बताइए. How much time will it take to half? Yes, Jiva, correct. It will again take 2 minutes. When I am going from 4 moles per liter to 2 moles per liter, then how much time will it take? Tell me, guys.
2 minutes.
Again 2 minutes. Very good. Okay, if I'm going from 2 moles per liter from 1 mole per liter, it is again going to take 2 minutes. Got it? Okay, ये बस आप लोग को एक आइडिया देने के लिए था, थोड़ा कंफर्टेबल करने के लिए था. आप लोगों को अजीब लग रहा होगा कि सर 8 मोल रिएक्ट कर रहा है तब भी 2 मिनट, 4 मोल रिएक्ट कर रहा है तब भी 2 मिनट, 2 मोल रिएक्ट कर रहा है तब भी 2 मिनट, 1 मोल रिएक्ट कर रहा है तब भी 2 मिनट. That is not the concern here. What is my concern? My concern is just the half. ठीक है? What is constant here? What is constant? The initial and the final are related as such. Final is half of the initial reactant concentration. So that is what you have to focus in the first order reaction. Okay, in the first order reaction, you have to focus on that. Now, Please see this number line, which is very important for you to understand. Let us suppose this is 0%. That means reaction has not started. This is 100%. So this somewhere here will be the half. This is your 50%. So for a first order reaction, this time will be equal to how much? T half. Okay, whatever the T half is, that will be the time. Now, again, if I look at this point from this point to this point, from this green point to this green point, okay, then the half of this will be somewhere here. And this half will also be equal to what? The time taken for this half will also be 20. It will be T half. And what will be this? This will be 75%. Now what I can say, time taken for 75% completion of reaction is equal to T half plus T half, right? That means it is equal to 2 times the T half. All of you got this? Yes or no? Please tell me, guys. You can also say time taken for 3/4 completion of reaction is equal to twice of T half. But these are all of these things are for what? For first order reaction. All of you done? Yes or no? Please tell me. ना लिख लिया आप लोगों ने?
Yes.
हाँ guys, बहुत बढ़िया.
एक मिनट सर.
एक मिनट. अच्छा, एक मिनट. हो गया? जल्दी बताइए, हो गया? आंखें बढ़े?
हाँ सर.
अच्छा, हुजैफा. फहद, आपको स्क्रीन दिख रहा है? नहीं दिख रहा अभी भी? यस फहद,
हाँ सर, अब देख रहे हैं.
दिख रहा है. All of you done? Yes or no? Please tell me. Is everyone done? हो गया लगता है सबका. चलिए. Now look at this concept, which is going to help you in so many numericals. Please write number of half-life. Then write percentage reactant remaining. Now, when we are in the first half-life, then the what we are having first half-life, then we have 100% on 100% of the reactant, and out of 100%, half of it reacts, and how much percentage is remaining? only 50% is remaining in the first half life. Is this clear? Yes or no? Please tell me, guys. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Okay. I can also write this as 100% upon 2 to the power of 1 is equal to 50%. Okay. Now, when we are in the second half life, we have 50% of the reactant only, because एक half life हो चुका है, एक half life में 50% बचा, 50%. Now we are having this divided by what? It will be divided by again 2. This will be equal to how much? This will be equal to 25%. Right? After second half life, only 25% of the reactant will be remaining. I can write this as 100% upon 2 to the power of 2 will be equal to 25%. Is this clear? Yes or no? Please tell me, guys. दिख रहा है आप लोगों को?
Yes, sir.
Now for the third case, we will be having 25% reactant is remaining divided by again 2. This will be equal to how much? This will be equal to 12.5%. I can write the same thing as 100% divided by 2 to the power of 3 will be equal to 12.5%. Will be equal to what? 12.5%. That means if we are in the nth half life, what we are in the nth half life, then I can write this as 100% divided by 2 to the power of n will be equal to the percentage of reactant remaining. Okay, percentage of reactant remaining. Chapiye, guys. Please write this down. Write it fast. Let me know when you're done. Okay. Right, next. T half for a first order reaction is 10 minutes. Calculate the fraction of reactant remaining after 60 minutes. यहाँ पे देखिए बहुत ही आसान सवाल है. Please listen here, guys. T half is equal to 10 minutes. Now we have to calculate. Please see what we have to calculate. What will be half-life number after 60 minutes? ठीक है, यहाँ पे ध्यान दीजिएगा आप लोग. It's very simple. Please ध्यान दीजिए. When it is 10 minutes, this is what is the half-life? It is the first half-life. Yes or no? Please tell me, guys. This is the first half-life. Correct, guys? Yes or no?
Yes, sir.
Yeah. This is Zan सही है, बहुत सही Zan. When it is 20 minutes, this will be what? Second half-life. Yes or no? Please tell me.
Yes, sir.
है ना? तो अब बताइए 60 minutes में क्या हो जाएगा? 60 minutes will be
Sixth half-life.
Yeah, very good. Sixth half-life, right? This will be sixth half-life. That means in order to calculate the half-life number n, half-life number n, it is equal to the total time, whatever you have the time, divided by the t half. तो हमको 60 minutes पूछा था, तो 60 minutes divided by 10 will be equal to what? 60 upon 10 is equal to 6. Now, percentage of the reactant remaining. Will be equal to 100% divided by 2 to the power of 6. सही है? बताइए कितना आ जाएगा ये आंसर? So this will be what? 100 divided by 2 to the power of 6 will be how much? 64. Okay, this will be in percentage. In fractions, this will be नहीं 1.56 नहीं हो 1.56 1.56%. 1.56% परसेंटेज में हो सकता है ये सर 1.56% लिखिए तब सही होगा. This will be what? 1.56% will be correct thing to write. Okay, but in fractions what I am going to write, this was in percentage, to divide this percentage by 100 and you will get the fraction. That means you will get 1 upon 64. This is the fraction that will be left. Okay,
So can you
please
scroll
write this down. Yeah, sure. Yeah, everyone done? Yes or no? Please tell me.
Yes, sir.
चलिए आज के लिए इतना ही. Then we will meet on Wednesday. Okay. I'm taking this short class because I am at where I am. I'm at hometown of my mother. So it is like अम्मी के नानी घर में है. So I have to visit some people, and then we'll meet on Wednesday, inshallah. Okay, we'll solve some more problems. And those who are from the mom, I hope you have started to practice questions for your half-yearly examination. Please send me doubts if you have any. Let me know if you need some extra classes. But like आप आज बता दीजिएगा तो हम कल एक एक्स्ट्रा क्लास किसी आधे घंटे का कोई डाउट होगा आपको तो हम वो ले सकते हैं. Okay, but please let me know. Okay, if you have any doubts in any of the concept or in any of the chapters. Okay. जी फहद कुछ बोल रहे हैं आप?
जी सर मुझे ये SN1 और SN2 में था डाउट.